In this video, we will cover Review Exercise 4 at the end of Tutorial 4 on pages 341 through 344 in the text. I highly recommend that you take significant time with this drawing, looking it over and familiarizing yourself with the contours and the different geometric elements as they relate to the dimensions. This is a very complicated drawing exercise. And once we do accomplish that, we need to read the instructions that follow as well, as these are the guidelines I will use to grade the assignment. So looking at this drawing, I can first see a few circles that have center points and a couple of lines. So those are my low-hanging fruit and my easy dimensions. I'm going to shoot for those first and then build everything around that foundation. The most obvious radius is at the far right end of the part. It's a radius 1 inch. It sits on Y0 and it shows as having an X distance to the center point of it of 2.625. So I'm going to go with that radius first, but before I do that, I'm going to create that rectangle that goes around the part. It's really going to end up being stock geometry, but it's also going to help us create the other geometry for the contour. So I'm going to create that rectangle now. Just go to create rectangle right here. Looking at my print, it is 8 by 6, and I'm going to place it to anchor it to the center. And there's my stock box. Now I'll go to that, check out of there, go to that circle center point that I was speaking of on the far right. It's got a radius of 1 and the location is X 2.625 and comma, Y is 0, enter, and there's our first circle center point. I'm not going to check out of this operation. I'm going to apply it because I see 2 more circles I can use. The next one is part the way up. It's the 0.5 radius. It's a female radius and it sits at X 2.5 and Y 1.845. So I put my radius of 0.5 in, go to my fast point. X is 2.5, comma, Y is 1.845, enter, and there's that small female radius. I'm going to apply it. I'm going to go for my third circle center point. It's actually the circle that sits at the top of the part, although it's dimensioned at the bottom of the part because this part is symmetrical and we're going to just mirror image it. So taking dimensions from the bottom, but placing it on the top, I've got a radius of 1. I have a X location, go to fast point, of 0, comma, and a Y location of 1.675. Enter. And there's the circle that's going to create the top of my part. Check out of that operation. There are 2 lines as well. Like I said, we're going to take the low-hanging fruit first. I have a vertical line and a horizontal line. They're both dimensioned at 2 inches off of the origin. This circle right here has a radius of 5 inches and it's also placed at 2.5 inches. So the tangent point here will be at 2 inches from the origin. I could analyze and check the distance if I'd like. Select the point or curve. I'm going to pick the origin and then I'm going to pick this tangent point here. Use your snap and it's going to tell me that it has an X distance of 2 inches. So that's a way to check yourself and make sure your math's right if you choose to use that. It doesn't count the angle, it's just counting the distance in the x-axis. So I'm going to create a line endpoint. tangent, which is already active. I'm going to tangent right off of this snap point here, and then activate my vertical and just place it up here a little bit. And I'm going to check out of that because I have to create my horizontal line, my little bitty tiny horizontal line that's actually shown with a dotted line on the other side of where we're working. But the only way I can think to do it is to create a parallel line off of the rectangle stock box. So I'm going to go to parallel. I'm going to pick this line. And now it says give me a distance. If I do the math, 2 inches from origin gives me 1 inch off of that line. So at 1 inch, I'm going to pick this side. And there's my parallel line. I had to do all of that just to create that little horizontal line that is so valuable to our contour. There's a couple other parallel lines I'm going to need down the road, so before I check out of this operation, I'm going to apply that and put those in as well. And they're basically one going straight up the middle and straight across the middle so that I can use them for trimming these circles out. So I'm prompted to select a line. Select this line. I want to go to this side, and I need to put an amount in. So off of that line, the origin is 3, and it'll put it right there. I need to apply that one. Pick this line. You don't have to pick these in the same order, obviously. Just follow your prompt, indicate the offset direction, and it's that way. So I put the distance in wherever I feel like it. But I need those 2 lines for now, and I will trim them out later, or actually delete them later after I trim. So now we need to put in our tangent arcs because we have good geometry with which to blend and create a contour. So I'm going to go create, arc, tangent, make sure that my 2 entities is activated. I have a radius of 4. I'm picking that one on the far right next to the 1. It blends with the 1. It's very, very subtle. Enter. And now I'm prompted to pick the entities. And those are all the variety we have to pick from. And if you look at your picture, this is the one we want. It's not concave, it is convex. And that's the radius we need. I'm going to apply that and do another one. I've got a radius 3 up here. So we'll change this dimension to 3. Enter. Select entity. This one comes off of this circle and it blends with the horizontal line. And looking at your picture, this is the one that we need. Basically, you just pick the one that you need. Check out of that command. First thing I'm going to do is delete this horizontal line now. Now would be a really good time to do some trimming. Get my scissors out. I'm going to use trim divide. It works really good on circles. For example, I can remove this half and this. Remove all of these because we're going to X-form mirror this contour once we get it. I'm going to zoom up on this and trim this out and that one and that, and there we have it. We actually remove that tangent point with the horizontal line. It technically was out here somewhere. That's why the drawing's so obscure. Check out of that command, select these 2 temporary construction lines and hit your delete button, or you can do your eraser up there. And now we are ready to start copying this. X-form, mirror, slide a box around that and click it. We are done selecting. We are going to copy this. We're going to copy it about this axis right here. and with 0 movement. In other words, if I would put some value in here, there would be a gap between the two sections. I'm going to accept that and stay in the command. I'm going to make another selection as I'm prompted. Slide a box around all of that, end selection. So we're going to rotate about basically the y-axis, and that looks perfect. So now we can check out of that command. I can clear colors. I think it would be a good practice right now to join all these entities, see how they're broken, and we can make it joined into one good chain. Technically it is a chain, but I just want to join them just to alleviate problems down the road. So that you can do edit, join entities. This comes in handy for a lot of things, so I'll just use it here to show you. Slide a box around all of our interiors here. Click end selection, and now it's saying some divided entities which are not connected but which are based off the same original entity have been found. Do you want to close the gap and join them? Say no to that, otherwise it's going to try to join like this vertical line and this one, and it'll draw a bridge across there, and we don't want that. So now I'm joined and I just feel better. So something I could show you just like I showed you analyze. So at this point we can build our ellipses. Create ellipse. Go to our drawing. We have a width of 3 and a height of 1.75. Enter. And now it's saying select a base point. I'm going to pick it right there. Apply that. Let's do the next ellipse. It is 2.75 by 1.5. Enter and anchor that to the middle, and there we have our ellipses. So we got through that geometry okay. At this point we just check out of here and go create our letters. So create letters. We need 101 for our verbiage, and we need Times New Roman, italic, okay. Our print calls for a height of 0.75 on these. It didn't give us a spacing, but it looks to me like it's about 1/4 of an inch. So I'm going to check out of that and just place this over here. Now before I can put it in the part, I need to create a bounding box around it. And what that is it's saying if you have a part, or say you buy a product and it's really randomly shaped and they want to give you the overall dimensions of every little tentacle and everything that's sticking off of it, that's what a bounding box does. And that way it can calculate the center of the entire odd shape, and you can place it in the middle of your part that way. So we go to create bounding box. Right now it's doing that because we have all entities. We need to uncheck that. Now it says select the entities. I'm going to slide a box over that and end my selection. I'm going to take lines and arcs off, and I'm just going to keep center point in there. You see it went in. So I'll check that. Now I can move it because I have that center point, and that's a true center point. Okay, so to move it, I want to go to Xform, Translate, select entities to translate. I'm going to put a box around it. I'm not going to use the change colors and quick mask means of selection that you learned in the tutorial. That was just really to show you how to use it. End selection, I want to move it from, select the point to translate from this point, select a point to translate to, I don't have one I can pick, but I certainly can enter some coordinates here. And if I go to the print, my x is 0, comma, and my y is 0.75. Enter, and there it placed it. So I'll check out of that. We had to create this geometry separately because it's different sizes. So we go create, letters. This time it's Mastercam. Obviously it's still horizontally aligned. We have our Times New Roman italic 10. Our height is 0.5 for these Mastercam letters, and our spacing is 0.01 per the drawing upper left corner. That all looks good. Now it's enter a starting location for the letters. Basically I'm just placing it, and that looks good. Now we need to put the bounding box around it. Create bounding box. Select entities. I'm just going to box them in instead of using the colors. And the quick mask. End selection. And I want a center point. So we just check out of that. Now I've got that center point. So now I can go to Xform, translate, select entities to translate. I need to box it again. End selection. I want to pick from the point within that box. That's why I need to box it all. If you try to just pick the point, it'll just take the point. There's the point. Now it says select the point to translate to. Go to my fast point. Again, x is 0, comma, y is negative 0.75. Enter. And it looks like it's going. If I check the box, it'll be there. I'm going to fit and clear colors. And I believe that's all the 2D geometry we need for this part. The depths will be handled in the linking parameters of the cutting operations, the toolpath. So we can start setting up a machine and some stock. Okay, so I've got my default mill selected. Tool settings are the same as usual. Stock setup, rectangular, Y6, X8, Z 0.5. The origin is in the center of the part, and the coordinates for that origin are all zeros. We'll keep that. Now I'm instructed on page 343 to create a 2D high-speed core mill toolpath. Select that name. I'd like you to put your name in all of your file names if you could. Okay, now we're instructed to define chain 1. I'll pick that chain, reverse it to clockwise. Define chain 2. That will be the contour of the part. I'm going to reverse it to clockwise. And we are complete. That does make one single region, and we'll keep that. Toolpath type is the core mill. The tool is the 1-inch end mill. We're going to machine the outside, contour. This will show up as verbiage in your program. It's very important when you're sifting through the program. We're not messing with holders for a while. Cut parameters, we are instructed to enable corner rounding, and I don't want to leave any stock on walls or floors, so I put zeros in there. Everything else looks fine. We're asked to enable depth cuts, so pick something. We have to go a 1/2 inch through the part, so I'll pick 0.2. That should leave me 3 cuts. Actually, you should be able to cut it 1/2 inch deep with a 1-inch cutter. It's usually half the diameter that you can cut depth-wise or on the side. So, but they want us to use depth cuts, so I'm using it. Transitions, we are asked to just pick an entry method. Helix at the 250 thousandths radius is perfectly fine. We will use breakthrough here because we are going to go all the way through that rectangular stock. I'll go past it 50 thousandths. I'm sorry. And then our linking parameters. Our clearance is standard 2 inches to take care of any types of clamps or holding devices we may have down. Retract is when it comes off the part. Feed plane is where we start to cut. That's the one item you should use incremental for because it's 100 thousandths from wherever you're going to start cutting. All the rest should be absolute. Top of stock is 0. Depth is -0.5. The breakthrough will handle the rest. Technically this is absolute or incremental would work for depth if your top of stock is 0, but it's a good habit to stick with absolute in case you change the top of stock for some reason. So that looks good, and we'll take that. And we will verify very quickly. Isometric fit. 1 layer, 2 layer, 3 layers. Looks good. Okay, next we are instructed to remove the material at the step using dynamic core mill. Tool paths, 2D high speed, dynamic core. I'm instructed to define chain 1, which would be that chain, and chain 2 would be this chain. We're going to cut a step in that area. As you can see, they're both lit up, so we're good. Yes, it is a single region. Dynamic core mill. Tool is the 1 inch again. We're going to machine the step. Cut parameters. Basically, we don't want to leave any stock for any reason. Everything else looks pretty good. Depth cuts is already disabled. We won't be needing that. Entry motion, stick with the helix with the 250 thousandths radius. That's fine. Obviously no breakthrough. And our linking parameters are all the standards. And this step is -0.250. We'll go ahead and select all and verify. See how it runs. It looks good, and I don't see any stock. Sometimes I'll forget to leave 0 stock, but I didn't that time, so we're good. Now we're asked to pocket out the center. Go to tool paths. Pocket. We're going to use the window this time, just like we did in tutorial 4, and capture the letters and the internal ellipse only. I'm right on the line there, but we'll find out. Now it says to sketch an approximate start point. Okay, I missed my ellipse because I got on it a little bit. If you don't encompass something completely, it won't be selected. So I'm going to escape out of that and retry it. toolpath, pocket, window, everything's inside now that I need, the internal ellipse and the letters. Sketch a start point, just click right there. Everything lit up well. We're ready to go with that. It's a pocket. The tool itself is a 1/4 inch flat end mill. I'm going to go to the library. Equal to 1/4. There it is. We'll pick it. Machine pocket. You can put anything you want in there. Whatever is meaningful to you when you're looking at a bunch of G code and a program. We're not doing holders, cut parameters. We need the standard pocket, leaving no material on walls or floors. In roughing, we're going to choose the constant overlap spiral per our instructions on page 343. The entry motion is helix. There's not going to be any finishing here because we're going to remachine it later. So we'll disable that. No depth cuts on this or breakthrough. Linking parameters. Our depth is negative 0.125. Looks good with the generation. Might as well run it. Isometric and fit. Very nice. So now all we have to do is remachine with the finer end mill and clean the rest of that up. But we didn't want to do the whole thing with a 1/16 inch end mill. It would take forever. So we hogged out as much as we could, and now we're going to finish it and pick out those corners. So we go to toolpaths, pocket. We already selected everything from last time, so we can just use the last button. Say yes. It is a pocket. The tool is going to be a 1/16 of an inch flat end mill. I have to go to my library. 1/16. Enter. There it is. We'll pick it. I could say remachine or finish pocket. Cut parameters, we want to go to remachining for sure. There is no stock being left. This is the operation we want to remachine. The standard pocket. We want to disable display stock, machine complete, finish passes. Step over percentage is 55 according to page 344. The entry motion is off for some reason. We're going to use depth cuts with a maximum rough step of 0.0625. There obviously is no breakthrough. Our linking parameters are the same all the way down, except that our depth is negative 0.125. Looks good when it generated. Let's go ahead and verify. Isometric, fit. And there's our remachining, picking out all the little stuff that the 1/4" end mill had left behind. I think that looks like a good part. I'm going to middle mouse and zoom up on it and take a little closer look. That's what you need to do. So good luck.